Welcome back to Algebra 2, Chapter 2, Section 2, and last time I forgot to change the board. It still said 1-7, that was 2-1. So everything I'm teaching right now is Algebra 1. We're not going to get anything new till I think 2-7. So if any of this is too fast, go back and watch the Algebra 1 or even pre-algebra. I teach this in pre-algebra 2 and I do it slow. So I'm doing it fast because I'm just reminding you what I hope you already know. Okay? So don't freak out that I'm going fast. I'm going to go slower when we get to new stuff because there's review, so we're just touching on it. Alright, so what is the symbol for slope? Do you remember? You'd think it'd be S or maybe SL. No, it's M. M. It's the M of y equals mx plus b. Slope, the coefficient of the x term is m, which there must have been a big fight and all the words got together and they were fighting over who got their initial, and slope lost. So unless they changed their name to mope, we could do that. We could change the name of slope to mope. How do you think? You think that'll work? Alright, so in this equation, this is linear, no exponents, the slope is 2. And what does that mean? The slope is rise over run. This is what I think of the old-fashioned way. The change in y over change in x, change is the Greek letter delta. It's a triangle and it means change or difference. So in science and math from now on, you never have to write change or difference. You can write a triangle and it is considered just the same as writing the words. And then the formula is y2 minus y1 over x2 minus x1. And if all that sounds foreign, either go watch the other videos or just see if you catch it as I teach it right now. Okay, so what does that mean, rise over run? It means the up on top in the numerator, the over in the denominator of a line. And how I think about that is, here's my little football player and he's running out along the x-axis, and then his friend is sitting up here in the stadium, and in choir they call these things that go up like that risers, don't they? So he's in the risers, he's in the runners, so the rising up is y, the running out is x, so it is rise over run, y over x. Now what about this? The very first thing you do with a problem is you have to label which ones are the ones and which ones are the twos. And how you do that is you look just at the x's, and whichever x's is less, those are the ones. So 1 is less than 3, so this is x1. That has to be y1 that goes with it. We don't even care with y1. With the y's, just that they go with their x's. And then so this is x2 because 3 is more, and y2 then is 4. Okay, so then you put them in those formulas, and I'll show you how over there. Now, also slope can be thought of as a rate of change. So here is two lines. This one is steeper. It has a steeper slope, so it has a greater rate of change. This one, the red one, is flatter, so it has less of a rate of change. And so slope is reflected with rate of change, and especially if you're graphing something like speed. Okay, so now there's other things about slope I want to show you. If the slope in this first quadrant goes up, it is a positive slope. If it goes down, it's negative. So I think of this like the stock market. The stock market's up, yay, we're happy. The stock market is down, boo, we're sad. If it's a flat line, it's zero slope. But what about if it goes straight up and down? Like this line, say this line looks like it's x equals 4. Is it a line? Can we graph it? Yes. Is it a function? No. And its slope, if you divide this, you'll end up getting, say this is at 4, and that this is at 4, 2, and that this one's at 4, 1. If you subtract 4 by 4 in the denominator, you're going to end up with a 0 in the denominator, and that's not allowed. We're never allowed to have 0 in the denominator in math, so you'll get error on your calculator, and it is said to have an undefined slope. We can't define it because it just says error on our calculator. Okay, now what about if they're parallel or perpendicular? Parallel, that's not all 11, that's the sign for parallel. Parallel lines have the same slope, and mine are drawn poorly, but you can imagine. These go on forever and ever like the rails of railroad tracks where they will never cross. They'll just forever stay at equal distance apart. So here I have two lines, x plus 1, so you go to 1, and then the slope here is an understood 1, which means 1 over 1. So the slope is over 1 up 1, over 1 up 1, over 1 up 1, and we can get our points for our line. This one, the y-intercept is -3, I put a dot, and this slope is also over 1 up 1, over 1 up 1, over 1 up 1, and I can graph them that way. And that's one reason why we like that slope-intercept form. So like this line, its intercepts at 3, you go, it's got a 2 here, so that means that has an understood 1 in the denominator. You go up 2 over 1, up 2 over 1, up 2 over 1, and there are your dots for your line. And then you can put your ordered pairs down and you've got a great line. So you can think of each over up as a little right triangle. And the hypotenuse is what the line does. The over part is the x component, the up part is the y component. And this gets really important in physics. And a lot of you do physics and Algebra 2 together. So make a little note, this will be important in your physics class. Okay, if something is perpendicular lines, then you take the slope, you flip it, and change the sign. And when we flip things, we clap. Turn up the radio, blast the stereo louder, and flip it. Flip it. So that's gonna, you flip it. Put it in your brain, it will put it in your brain that perpendicular, you flip it, and change the sign. Now your book says you think of what you would multiply to get, don't do it. Do it my way. Flip it. It's more fun. Flipping's fun. Flip it and change the sign. Alright, so here are my two lines. This one is x2 plus 3, so I go 3 and put a dot. I go up 2 over 1, put another dot, ching, there's my line. This one is going to be perpendicular. I go to 1 and put a dot. Then I go down 1 over 2 because it's negative. Down 1 over 2, put a dot, and it's a perpendicular line. It'd look really good if I had done it on graph paper. Now on your calculator, when you graph, a lot of times your perpendicular lines won't look perpendicular in the standard window. You have to go to square. So under that second trace option, go to square and you'll see it. Make sure you're watching the calculator videos that go with this class and you're doing those assignments. Calculator is so key to doing good in this class, and college algebra, and the SAT, and the ACT. Alright, so here's a slope problem. What is slope? Excuse me. We're given 2 points. Step 1, you figure out which ones are the ones. 3 is less than 1, these are the ones. Step 2, I write my formula. Slope equals change in y over change in x, y2 minus y1 over x2 minus x1. I write the formula every single time. That makes it where I memorize my formula and I don't get to the SAT and go, there was some formula for this. Also, I'm going to cheat and show you how to do this problem right here on your calculator under linear regression. So go find that video and you can learn how to so-called cheat with your calculator, but it's not really cheating, they allow it. But right now I'm teaching you 1987 style, baby. Okay, so now we go find y2 and we write it down. Then we write our equal sign down before we ever look to see what y1 is. Because if y1 is negative, you will drop a negative and get the wrong answer. I've taught this for decades. I know where you make a mistake. That's where you make your mistake, not writing your minus down first. Then you go to x2, write it down, minus x1, subtract, there's your slope. Here's another one. You go to label your x1, x2, and you notice the x's are the same. As soon as you notice the x's are the same, you don't do the problem, you write undefined, and you're done. because that means that's going to be a 0 in the denominator, not allowed. All right, come back for more Chapter 2. Math is great.